Alright, so these are the questions on the law of cosines homework. This is John, by the way, in case anyone is confused. Alright, so for this problem, I would start off solving for b squared, which would equal a squared plus c squared plus
minus.
Oh goodness, that's what I did. I think I did plus.
Well, there we go.
That's why I was wrong.
That's all right. So
Minus 2ac times the cosine of b. And then I'm just going to skip steps here. Is that okay?
that's fine. That's what I would do.
Alright, cool. I'm going to skip steps.
Just say b is equal to.
Oh, yeah. b equals the
Okay.
square root of 8 squared plus 13 squared plus... No, minus.
Okay, you know what the good news about this board is that you can hit this.
I know, and I can actually erase.
And hold on, don't hit that because we want the small eraser
Yeah.
there. There we go. Right? And then
Okay.
you just hit the ink again. There you go.
Alright, sorry about that. So, minus, this is why I got this problem wrong. 2 times 8 times 13. I'm just going to write this down here, times the cosine of 131 degrees.
Okay?
Okay.
Now hit the pointer.
Oh, the pointer is
Which
right there?
No, down low. Oh, you did it. Okay, now get the calculator up.
Which is right there?
Yep.
You're going to drag this over here? Oh, okay. Oh, no.
No, okay, so do that, and then what you're going to do is drag it to the lower left corner. So all the way down to the lower left, and it'll pop up, not that far,
Okay.
midway.
Yeah.
Further to the left. Further down a little bit. We got to catch it so it'll do half the screen. Here, I'll show you. Oh, why isn't it doing it? Hang on.
This is going to be the most interesting set of notes. Okay.
I don't know why.
Alright, cool. Well, now we got it.
We scroll that over so we can see what our numbers
Yeah.
are, and then we can do it on the calculator.
Okay, so you got second square root 8 squared plus 13 squared minus 2 times 8 times 13 times cosine of 131.
Close the angle,
Close it,
pop off with the square root, there you go.
and then enter. So for B, oh, draw. For B, that would equal 19.22, is it meters? Or is there not, there's
Just
no label?
units, that's fine.
Yeah, we'll just go with units. Okay, so now we want to solve for the angles A and C. So let's start off with cosine of A would equal
Here,
b squared plus
you're gonna need more space, I think,
yeah, I think so.
or no. Let's just move it down a little bit.
Okay. 16 page. Cool. Okay.
I think.
Alright, b squared plus c squared minus a squared all over 2bc. So you're going to use the inverse cosine, and you're going to plug in all those values that you had earlier, which are right here. Oh, but you should also stow that. So we'll go stow alpha a. So now we
You
have...
wanna stow it in B? Because it was
Oh,
actually
yeah.
a little B.
We'll stow in B since, you know, we just solved for those B. So now we have that stowed. So now we can plug this all in. So second cosine of alpha.
Well, we gotta do the
Oh, yep.
parentheses, right?
Gotta parentheses it.
Yeah.
Second, nope, it's alpha v squared.
Yes.
Did I do an I? Oh, I did alpha. Thank you.
You're in alpha lock right now.
I'm an alpha lock.
So just hit alpha there, you're fine now. Now you can hit the square.
Okay.
You hit second alpha, that locks it to
Got
the
it.
alphabet.
Okay, alright. So now b squared plus c squared and c is equal to 8, so we got 8 squared minus 13 squared, close the parentheses, divided by,
Open the parentheses.
open the parentheses, 2 times alpha b times a 8.
Yes.
Close the parentheses. Enter. So, cosine, well no, just angle A.
Yeah.
I can erase. A is equal to 30.69 degrees. Okay, and now we're going to do cosine of C.
We could do that, or scroll up.
Oh, or, you know what? We're going to make our lives a lot easier.
I like the way you
And we're just going to do 180.
Right.
Not so. I can just erase that cosine. So we're going to do 180 minus 131 minus 30.69, which C is equal to, come back to our calculator.
Pointer.
Thank you. 180 minus 131 minus,
Alpha B.
you can do alpha b.
Oh, no, I'm sorry, you're right.
Okay.
Second answer.
Yeah. And then 30. Oh yeah, second answer.
Yeah, because or you can just, you know what else you can do?
Oh, I can just go up. Yeah.
You just go up there and grab it.
Well, I gotta delete that first.
Yes, you do.
Up. Enter.
Good.
Enter. So now C is equal to up. Go. 18.31 degrees. What a process.
All right, and then you can also copy your screen here so you have a record of what you did.
And file.
No, just hit the camera.
Oh.
And then hold your finger down on that. Lift up. Copy. And then minimize that thing. Or just touch this board. And then you're in ink mode. So now press the board down a little bit. Lift up and paste. And there's all your calculator work.
Oh. Yeah. Okay.
Beautiful.
Well, sweet. There you go.
All right.
Well, now I know what I did there because I started off with the wrong formula.
Well, and that's good. That's just a simple thing to fix. So.
Yeah. Okay. So now we know. Now we don't have to do that giant thing again.
All right. So let's arrow to the next problem. Let's see what the next problem is.
Okay. Oh, right there. Okay. 17.
Okay. And so we're going to hand the baton off to
Mary.
Mary.
Oh. You got it. Sorry.
Okay.
So
There was a little baton toss there that.
use blue. Okay, so draw your triangle, what they give you. So I put A on the bottom, put the 47 degrees here. Then I put B on the bottom, and 32 as little b, and C at the top, and 19 as little c. And then your equation for this, triangle area equals 1/2 little c, or little b, little c, sine of A.
Which Mary's, we're going to go over that today. So it was
Okay.
good of you to look that up.
Okay, so then this one's pretty easy. So your equation is just 1/2 32, which is little b, times 19, which is little c, sine of A, which is 47 degrees. And that will give you 222.33 feet squared.
All right. So Boston, that's great. All right. Yep. And that's finding the area of an oblique triangle. And I'm going to go over that formula in just a little bit here. Okay. So let's see what the next problem is. Is that it?
36.
Okay.
I thought that
Oh, it's number 1 up here.
Yeah.
That's what I did. All right, I'll do 36 because 36 is it looks more complicated than it really is. Okay, and so we're going to find the distance from the center of the front edge of the pitcher's rubber to the far corner of second base. So what we're trying to find is this distance right here, right?
Yeah.
All right, and they want to know how it compares this distance from the pitcher's mound to second base from the pitcher's rubbers. They want to compare this distance to C. So the first thing we have to know about a baseball field is that if you have 90 feet between home plate and first, that this is 90 feet here. Right? Because from first to second, second to third, all of that is 90 feet. And you might not have known that. But and it's a square. So these are all right triangles.
So these are all 45.
Right, okay, so just try to visualize here. I'm not sure if that's right exactly, but this is 90, this is 90. What kind of triangle is that? You might have just said it.
45, 45.
It's a 45, 45, 90, which is an isosceles right. So this is 45 degrees. This is 45 degrees. And what is the relationship between the sides on a 45, 45, 90? X and
X root 3.
x root 2. So x here is 90, right?
Wait, I thought the hypotenuse was 90.
Oh, it's not 90 degrees, it's 90 feet.
So the legs are 90?
Yeah, they're 90 feet.
Okay.
I'm sorry, I didn't mean to put degrees there. This is feet. I've got a lot of 90s going on, right? The angle is 90 degrees and so are the sides. Okay, so if the sides are 90 feet, then this distance here is going to be what? 90 root 2. Okay?
I'm kind of confused on why 90 isn't the hypotenuse.
Well, because if you did 90 squared plus 90 squared, let's do that. 90 squared plus 90 squared equals c squared, right? 90 squared is going to be 81, is it this? Do that on the calculator real quick, make sure I'm right.
Yeah.
And then add those together.
Mm-hmm.
We get 16,200.
Mm-hmm.
Oh my gosh, I'm adding in public again. Hide the animals. Okay, I'm going to take the square root of both sides here. And can I say that this is 162 times 100 here?
Yes.
Right, and I know this, then I can bring a 10 out. And then 162. What else goes in there? Perfect squares. I know 4 does. 162 divided by 4?
45.
No, it doesn't. Okay, by 2. What's 2? 162 by 2?
81.
81.
So 90 root 2.
Okay, so 10, and then this is square root of 81 times 2, so I can pull a 9 out. So this is 90 root 2. You see that now?
Well, from the picture, it looks like the 90 feet is the hypotenuse, is what I was confused.
Oh, okay, all right. So, did we even need any log cosines or anything for that? So for part A, we can say that the distance here to second base is going to be 90 root 2. How about if I call, if this is A, B, C, let's call this D up here. May I call that D? So I can say the distance for BD is equal to 90 root 2 minus 60.5, right? Because I would take this whole hypotenuse and subtract the 60.5. So if you do that on the calculator, Mary, what do you get? 66.78 feet. All right, now they've asked us to compare it to the distance to first base. Well, do I know that distance?
No.
No. But if I were to pull that triangle out, whoops, I should make it a little bit more realistic. Right, that's the home plate. And then this is 45 degrees. And this is a little bit more than 90, I think. It's not quite. Okay? But I know that this is 60.5. And I know that this is 90, right? So what kind of triangle situation do I have? Congruence theorem wise.
Oh, side angle side.
Side angle side. So if I wanted little side C, right, because that's what it would be. And this is B up here, and this is A. We could use the law of cosines for side angle side, which is C squared equals
A squared plus B squared minus 2AB
times the cosine of C, right? Okay, so we know that C is going to equal then the square root of A is going to be 60.5 squared plus B, which is 90 squared, minus 2 times 60.5 times 90 times the cosine of 45 degrees. So one of you guys do that on the calculator.
Okay. I got it. Second root 60.5 squared plus 90 squared minus 2 times 77.71. Am I right?
I got 63.
Do you have to
Are
get,
you in radians, John? Check your.
Oh, yeah, I am. I'm in radians. Sorry.
All right. So what'd you get?
I
Mary?
got 63.72.
All right.
I don't know if that's right.
Yeah, that sounds right.
Yeah, I got the same thing now that I'm in.
In degree mode.
Yeah.
Yeah. Okay. All right. So so if we're comparing the distance, which one's bigger?
The C.
Right. So the distance, it's a farther throw from the pitcher to second base than it is from the pitcher to
First base.
first base. That's kind of what they're trying to illustrate. Okay.
So it's a longer throw to first and to second?
No, to second.
Oh, well, obviously.
I might have said it backwards, Mary.
How much do they take? How much does the camera pick up? I mean, does the microphone pick up?
Everything.
So they can hear me talk
They
right
can
now?
hear us talking. Yes.
Sometimes, like, you hear, like, it's like a muted voice in the back asking a question.
Yes.
So I don't know how close the range is. So if I went up and just screamed in it.
Yeah, but let's not
I won't.
just scream in it. Our audience might be offended. Yes. All right. So now they want us to find angle B in this triangle here, right? All right. So
Is angle B where it has the arrow? Or is
yes,
it-
this is angle B right here. So we're going to use the law of cosines again, right?
Right.
And we can
You're like the
B equals, right? Can we do, okay, this is part B. And the glorious thing about electronics is that I can copy this and bring it down here.
No, for angle B. Are we gonna solve for the big triangle, or just?
That is the big angle, I believe. We're solving for the big angles.
so it's
Oh yeah, I meant like, but you're not solving for the whole like half of the.
No, if
half
we're
of the
solving for
time.
this one.
Okay.
So B squared equals
No, that's an angle. This is an angle. We're solving for an angle now, so we need.
right. But
Cosine
can
B.
you figure out like cosine of B? What cosine of B equals
Yeah,
from
right. That's what I was gonna.
Oh, okay.
Yeah, okay. Or can you go directly to what the angle equals?
Cosine
B equals inverse cosine of,
A squared
good, A squared,
plus B squared
C squared.
or minus B squared or plus B squared.
It's A squared plus B squared. Sum of the squares of the other two,
Right.
minus
B
B
squared.
squared.
b squared, good, all over
Negative
2 times these two.
AC.
All right, so b is going to equal inverse cosine. Let's write it out here. A is 60.5, right? 60.5 squared plus c squared, which we just found out was 63.72,
Yes.
minus b squared, which was 90. Squared all over 2 times 60.5 times 63.72 squared. I mean, not squared, but. All right, so angle B is.
We're getting there.
That's fine.
I got a dimming error.
Okay, so let me.
I'm trying to get it right now. So 3 times 60.
Oops.
65.
All right, so we need C, right?
I have 92.84.
I think that's right. But I want to show you guys a technique, if you don't mind.
Go for it.
On the calculator that I learned yesterday from Will about doing this on the calculator. It's really cool. Okay, so do we know what the values are for A here? We know it, right? What is it, 60.5?
Yeah.
60.5, and I'm going to stow this in alpha A, okay? And what is it for B? What's the length for B?
90.
90. So I'm going to take 90, and I'm going to stow it in alpha B, right? And then I'm going to take the expression up here that I did for C, and let's do second square root. I'm going to work it out here. That's going to be
Alpha A
alpha A squared
plus alpha B squared
plus alpha B squared minus
alpha A
2
times
alpha A alpha B times the cosine of 45, I think, right?
yeah.
See? That's the number you got?
What is that?
That side C that we just found up above here, right? So where am I going to stow that?
Oh,
Alpha C. So we're going to stow this in alpha C. And now I have all my sides stored. Okay? And now I can say inverse cosine of, open the numerator, and, oops, it went over here.
alpha A
And I'm going to just use these.
yeah.
So we're going to say
Alpha A squared
alpha A squared
plus alpha C squared
plus alpha C squared
minus alpha B squared.
minus alpha B squared.
Close parentheses, divided by, open parentheses, 2 times
Oh, I didn't open my parentheses. 2 times,
alpha A, alpha C.
and you don't even need times.
Yeah.
You can just do it like that. Close the, and then, oops, I didn't mean to do that. Of course I didn't.
You gotta do 2 parentheses, right?
Yes, I got to do one more. And I hit 10 instead of the parentheses. Enter.
Yeah, I got 92.8.
Is that what you got?
I got 92.84.
Well, but
But I probably used exact.
you had
Yeah,
some
I used approximations.
approximations. So this is kind of a cool technique, isn't it?
Yes.
I like it a lot. That's Will Cadell. Mrs. Muller, could you do this? I'm like, yeah. I really like that.
Ooh,
I really did like it.
And that was B, right? That was the answer.
Yeah, that's B. Now that's angle B, right? So what did we do? We stored all the sides.
Right.
yes.
Now, if you wanted to store the angles, you couldn't store them in A, B, C because you've got the sides in there, but you could do the angles D, E, and F.
But would it override them if you stowed, like if you decide to stow the angles there, would it override?
It would.
Okay.
And so, I wish you could, have big A and little a. That would be really cool, but you can't. All right, so those are the questions on the homework. So let's go on to the really quick notes.
Let's do it.
Let's do it.
And then there's only like 8 homework problems.
There are only 8 homework problems. I like the way we think, huh?
Do they like take a while or
No.
Generous.
We'll be getting the review on Friday.
You can have it today.
Ooh, you guys are missing out.
Right. All right. So finding areas of triangles. For side angle side cases, it's really simple to find the area of a triangle. And let's draw this where I have this very first one here, where I have my A here, and this is just a random, that's an oblique, okay? And I'm going to put B here and C here.
When you say that's an oblique, what do you mean?
That has no right triangle. I mean, no right angle.
Got it.
Okay? All right. Or maybe I should do it the other way. I don't know. We're going to try it out. Okay, so what happens here? When we're doing this is little c, right? And this is little b. And this is little a. Actually, I think I want to switch my letters in this case. Let's make B up top here so we can match the formula. I think that's how it's going to work. This is little b down here, and this is c, and this is little c. All right, so we know from geometry days, right, that area equals 1/2 the base. Now, this is not little base here, right, times the height. Remember that? 1/2 base times height?
Yes.
Yeah, okay. Well, this triangle doesn't have any right angles in it, and so I need to drop a perpendicular here, right? This is H. Right?
Yes.
All right, so let's say this is not A, this is area here. I need to know what the base is. Well, is the base easy to find here? It happens to be the same letter. So this area is going to be 1/2 the base times the height. But what is the height? It's this color, nobody's going to be able to see it.
The sine.
This is H, right?
Yeah.
What's A? Okay, so I could use angle A here.
Yeah, H is equivalent to the sine of
H
A.
equal, well, I could say sine of A is equal to H over C, right? Because this is the right angle. Sine of A is equal to H over C, opposite over hypotenuse,
Oh, yeah.
yes?
But then you want to get.
I want to put an H here, right?
Yeah.
So what is H? H equals little c times the sine of A. And so you put C sine of A. Okay, so these formulas are basically the same that you always knew. It's just this is the height. This is the height. This is the height. Okay, instead of H, you don't have to drop a perpendicular, it's being dropped for you.
So Heron's formula is for finding the angle.
No, that's
find
that
the
area
area.
for when you have side, side, side. But I'm not there yet.
Okay, sorry.
So when you have a side angle side, how do you know if you have a side angle side? First of all, these two letters are different. The B and C is different than the A. That means they're on either side, right? The AC is different from the angle B, and the AB is, right? The included angle and the two sides. All right, so this is so simple, it's scary. But we're not going to be scared, right? So the area here is going to be 1/2. Is this a side angle side case?
Yes.
Yeah.
So we use the two sides as 1/2 times 5 times 8 times the sine of the angle between them, which is 135. So can you guys multiply that out for me? What?
I got 14.14.
Okay, 14.14. That's the area. And we would say units squared. Okay? Now we could get to this very same conclusion if we dropped a perpendicular. You know, we dropped a perpendicular and then used,
1/2 times height.
yeah, right. That's, you know, right, exactly. So, it'd be crazy. Well, I wouldn't drop the perpendicular there because I knew the one thing.
It'd be a lot harder.
It'd be, right, it's a lot harder. But, so if you have a side angle side situation, it's just 1/2. Here we go, let's do it. The 1/2. The area here is this a side angle side case?
Yes.
Yes.
Oh, and the area, this is miles, so I can put miles here. All right, so it's going to be 1/2
Times 16.
times 16
Times 7.3.
7.3 times
Sine of 29.
sine of 29.
Okay, so that is 28.31 meters squared.
Meters squared, very nice. So does it matter what the letters are? It doesn't. You just have to have a side angle side case, and it's 1/2 the two sides multiplied together times the sine of the angle between them. Okay? Really, really simple stuff.
But it has to be sine angle side, right?
Yes.
Got it.
You have to have the included angle. What do I mean by included? That the angle has to be in between the two sides. Yeah. All right, Herons formula. Heron was an older guy. He was a mathematician and a scientist. He's also known as Hero of Alexandria. And he's credited for this formula. And although it's been thought that actually Archimedes came up with it, so they named it Heron's formula or Hero's formula for him, even though it may have been Archimedes who really put it all together. But I'm not going to go through the proof on this. I can hand you out a proof. It's like a couple of pages long.
Okay.
So we're just going to use it, if that's all right. You okay with that?
Yeah, I don't need to see 2 pages.
Of algebra? All right, well, a formula, and this is for side cases. If, for example, you know all the sides, you need to come up with something called a semiperimeter. Anybody know what a semicircle is? What is that? Half a circle. So a semiperimeter is nothing but half the perimeter. So let's label that S. So you can say S equals, you just add up all the sides and divide by 2. Because it's half of the perimeter. And then Heron's formula is the big square root here of S times S minus A times S minus B times S minus C. All right, so let's see what happens here. Let's find the area of these triangles that I have here. So the first thing we have to do is find the semiperimeter, which is S, which would be 9 plus 13 plus 16 all over 2, which is equal to 19. So the area is going to be equal to the square root of 19 times 19 minus 9, 19 minus 13 times 19 minus 16. And I don't even take the time to simplify that. I type that all in the calculator.
It doesn't matter what numbers which.
No. Now, how do you suppose you're going to know if you have no triangle?
If that equal, or if like one of the sides is 19.
Or
19.
or bigger, right? Or you have a negative number on here or it's 0. Yes.
I have an answer.
I would love to have it.
Area is equal to 59.76 inches squared.
Okay. And Mary's right. You're going to know you don't have a triangle if one of these measurements here is either negative or 0. So it's a really quick check. All right, so let's do the semi-perimeter on this next one. That's going to be 10 plus 9 plus 16 all over 2.
I got a different number.
Uh-oh, she got a different number.
I could be wrong though.
Let's check it out, John. Let's.
Oh, got a different answer than me. Okay. So second square root of 19 times parentheses 19 minus 9 times 19 minus. Oh, I think I know what I did wrong.
What'd you do?
I didn't put.
Parentheses in between?
I didn't think they had to put everything in parentheses.
Yep, you do.
Yeah, so I didn't put one of them in parentheses.
All right, Mary, what did you get? John's about to confirm it.
I got 58.48.
Let's see what you get, John.
19 minus. 58.48. Is that what she said?
Yes.
Yep.
Okay.
Sorry.
That's all right, happens. What's the semi-perimeter here?
17.5.
17.5. All right, so the area on this one is going to equal the square root of 17.5 times 17.5 minus 10. 17, I'm going to run out of space. So I'm going to write smaller. Area, ooh, I don't need to write that small. That was a little intense. Let's do that. Oh, that's better. Area is, ooh,
What is it?
it's dashed. I don't want that either. That was weird. Well, here we go. It's equal to the square root of 17.5 times 17.5 minus 10 times 17.5 minus 9 times 17.5 minus 16. All positive numbers, which is nice. So we're going to get an area. What's the area?
40.91.
44.91?
Or 40.91. Miles squared.
Miles squared. John's about to confirm.
Oh, I just want to trust her though. Too lazy. Last time I did it, I was wrong. So. Alright, 17.5 minus 10 Let's give you dexterous fingers. 17.
Well, your generation should have that with all of the access that you've had to the cellular
true.
devices.
What's that last number again? Oh, 16.
16,